ICB of the deep learning, which is ICB number 10. In this ICB, we are learning about the ANNS and the recurrent neural network. In this use case, we are using the sentiment analysis on the IM database dataset. So there are 3 tasks on this ICB. The first one is basically all the tasks applied on a code that was provided by the instructor. So the code has, the first task is to detect the 3 mistakes that not making the code runnable. So that's the code. So the code that was provided by the instructor, it's not pulling up, but anyway, so first I have to detect the mistakes and then add embedding layers and then use the same code but run the 20 and use group data set that we used in previous ICBs. For the bonus questions, we have to plot the loss and the currency as we did on the previous ICB, and we predict this one. We did learn that before as well. So first thing, when I posted the, or let's say I copy paste the codes, and the first thing popped up is this variable is not stated anywhere. So that's the first mistake I detected. So this variable is the input dimensions. They weren't provided, so I use this code of line that was on the slides to run through the sentences, which is the review column on the Excel file. That's the Excel file, and then it runs through the reviews column to detect the sentences, or let's say to train the data or to read the data. Then this max review length, well, we get a number. This number will be passed to the input dimensions. So that's the first. The second mistake is when I did run the code, I faced an issue with the number of the neurons. So it's 3. How did I find that? With running this code. So this code told me there are neg and there are 2 more neurons that are on the Excel file. And then the fourth mistake was to replace the SingMod with softmax. Softmax is more, so that's what the softmax does. So instead of using the SingMod, the softmax is runs and they calculate the exact amount of hidden layers that is needed. So that's why it's usable for less dimensions. So going back to the code, so going back to the codes, that was the third mistake. So I kind of think that's a fourth mistake, which is the number of the words. So it was here 2000, but the actual one is 2470, where I got from this line of code. So when we run the code, that's what we get. So the plot was added here as well. So I did add the plots on the whole tasks for the extra bonus. So that's what we get. So here it shows the loss, and here it shows the accuracy. So it has a good numbers. So here it shows the train is going up, so it's not going down and then back up, which is a good number, or let's say a good result of the accuracy, and the lose is just going down, which means is a good result as well. So the second task was to apply the embedding layer. So in order to do that, again, I used the code that was provided by the instructor with the slides, which this one is preparing the data for for embedding. So I forgot to add the comments, but yeah, this is what it does. So it prepares the data for embedding, and then we use the max value and then state it as input dimension, and then pass it through the number of future, which is the sequential that we used before from Keras library. So in here we use the embedding, and then we must add the flatten, and then we pass the vocab size, and then we leave everything as it is, and then here is the plotting. When we run the code takes a while to run. That's why they are already run, and I showed them on the video. So the last one is the news group that we used in a previous ICP. We use it as well, and then we apply it. So in here I only added this number, those lines, which is takes, or let's say extract the data from the fetch 20 news groups, and then run it and then apply it on this ICP. In here I added predict model for the bonus questions. So that's the second answer for the bonus questions. But here it shows the unique attributes that we had are 20, so from 0 to 19 instead of 3 the other one. So that's why here it was changed to 20. Yeah, and that's the end of the ICB, and thank you for watching.